Yeah, welcome to this session of remote telemetry. This is a way of having cheap and efficient telemetry for telecasting your data to a remote location using a very cheap and easily available equipments. Well, I dedicate this session to my dear mom, who was an avid follower of all my articles and blogs that appeared all over the world. She was the inspiration of all my projects, models, and blogs. Okay, guys, welcome. In this session, I'll show you in the small presentation how to use these small low voltage LoRa communication devices on another cheap microcontroller ESP32. Get the effective head, the turbines are situated at the lowest level of that reservoir, and that area becomes highly remote. See, communication systems, see, because it's a very small amount of power it is generating, see, it never got any importance. Employees are deputed there, they go there, run the turbine, and then go back to the home. So small amount of power, whatever is generated, directly connected and goes to the grid system. But thing is that because of this this renewable energy has gained momentum over the last 4-5 years, so there was pressure for monitoring of the generation system. So their IT department tried to put some SMS-based communication system, but that did not work because that cellular system at that depth was not working properly. So at the beginning, when these turbines were set up, they had a optical fiber cable system for communication between the power plant and the switchyard, but that got damaged over the years due to flood and many other things. So they wanted live data transmission to the main power plant so that management can have a look at the welfare of the power plant operation. So that's how the whole genesis started. We had our disposal SX1276 or 78 LoRa devices, and in our country 865 to 860 megahertz bandwidth is available for use up to 500 milliwatt. So in this channel, in this frequency band, there are many channels available, but up to 0 and 7, if you see the picture on the bottom left corner, so these 7 channels are used mostly for commercial use. So remaining channels you can use for the personal use with a limitation of radiation up to 500 milliwatt, and at the same time you have to communicate to the Niti Aayog that you are going to use it. So that's the formality required for using this bandwidth. And there are 2 types of devices are available. One is the UART type, just having RX and TX on the top one, and the bottom one is a SPI device. So both these type of devices can be used for this purpose. But even then, there are distinct advantages and disadvantages between these 2 types of LoRa devices. The top one is the UART type, having only RX and TX, and the bottom one is the SPI type. So bottom one needs more GPIO pins, but the top one, the UART one, that is mostly available from ebyte.com, and that has got very good security features. At least 3 parameters you have to hard code in those LoRa devices. The top one, UART one, and which makes it very, very robust and very secured communication. Whereas the bottom one, you have only a software code embedded in the programming device by which you can control it. So I always prefer the UART one. And for the UART one, the radiation is also you can control by hard coding. I'll show you in the next slide. This is the RF setting module for the UART one, whereas the SPI one, you don't require any such software. This software is available in the internet. You have to put it on a serial to USB device, and you have to hard code these UART modules. Look at here, for these UART modules, there are a lot of parameters you have to set. One is the parity, then air rate, then power. Power is 24 dBm is around 200 milliwatt. dBm is called decibel milliwatt. So for this job, 200 milliwatt is sufficient. So I set it at 24 dBm.
Sir, one is how many devices can connect to LoRa gateway?
LoRa gateway. I'm talking about one-to-one communication. One sending unit and then receiving up to go for a different type of setup. The receiver should be open-ended, having no fixed channel. So that's a different um, um, way of designing that LoRa one altogether. The another problem came that earlier for the beginning they wanted to have few crucial parameters. To be particular, 6 parameters they wanted badly for the management decision. So these are generation for the each turbine, then each turbine water head at the input and the tail race, the downstream water head. So these 2 into 3, 6 parameters they wanted badly. So we set up a ESP32, and ESP32 has around a lot of ports are available, and there we used 6 analog GPIOs we used. In fact, for any pins of ESP32 we can use as analog or digital mode. And the machine, that was a SCADA machine, and they had a free SCADA card. Every machine in fact have a free SCADA card, and in one SCADA card they drive out these 6 parameters in 4 to 20 milliampere analog signal. Look, here is a problem we face, that our machine can take analog signal in the form of voltage, whereas the machine was providing 4 to 20 milliampere analog signal. So in fact, there are a lot of boards, small boards are available, which simply transfer your 4 to 20 milliampere into voltage level. Any voltage 0 to 3.3 or 0 to 3 or 0 to 5 or 0 to 10, any voltage setup you can do. But at that time, actually, in fact, we did this project at the height of pandemic when there was complete lockdown here. So we simply used 165 ohms resistor across the 4 to 20 milliampere this current level. So the voltage got converted into up to maximum 3.3 volt, 880 to 3.3, 3300 millivolt. And our ESP32 used to read that signal. We set our transmission power up to 27 dBm with a 500 dBm, but later we found that 24 dBm was good enough. In the SPI, SPI model also, those are available up to 24 dBm. So SPI model could have been used there. But again, SPI model has got a distinct disadvantage. These are mostly surface mount type device. Surface mount type device, their pins are not readily available. So we discarded SPI modules also for this purpose. Otherwise, SPI LoRa radios have got as a very small form factor. They have very small form factors. But we used only that UART type devices. Now look at the physical setup of this setup. These are the two antennas. One is the sending end and one is the receiving end. This is this length of this antennas is 34.54. From here to here it is 34.54 centimeter. But because of the wind, they actually was getting distracted by the wind. So we created a spiral at the middle portion. So it gives them strength besides having the entire antenna characteristics intact. So these two handmade antennas we used 12 SWG solenoid winding rate cable, good quality cable. That was also internally resourced, and this works very, very nicely. And this is the sending device. We used a small ESP32, then this LoRa UART module. We put a few heat sink here because we found that the data were coming once in 4 seconds. So it was getting little heated up, running on 5 volt 2 ampere. So we put a few heat sinks here. And this is the sending end device. It shows which data it is sending. Bear me with this handwritten sketch because it is highly improvised. The tricks are here. Apart from this is ESP32, This is the SSD 1306 connected on I2C, pin number 21 and 22. Then E32 TTL, this is the UART LoRa. This is connected to the any two pins. 16, 17 I have used here. It can be connected on any two pins and adjustment can be done on the software, Arduino software. And this is another I2C device. This is a real-time clock. This is connected to I2C again. And this is the SMPS 5 volt to 3.3 volt converter. And here the signals, whatever signals it is coming, 4 to 20 milliampere, we put a 165 ohms resistor across it. And 165 ohms resistor is again not standard resistor. So we made it using two 330 ohms resistor in parallel. And we have used 6 resistors here as a biasing. So internally they are connected to each signal to the ground so that there won't be any false signal. And the analog signals in converted into voltage by this resistors goes to these Arduino pins, and Arduino converts them into voltage level in the signal level. And this is transmitted via this antenna. This antenna wire is 120 meter length, right from the heart of this Handheld turbine, which is below the ground level, and goes to the roof of this building around 120 meter, crossing all the walls and windows and every with this crisscross way. It goes up to that many length. The output here, every data arrives in once in 4 seconds. And in fact, ESP32 is such a good microprocessor. It's a very good quality microprocessor, rather very powerful microprocessor. We never miss any data. We hardly miss any data because the signal is very good. The line of sight is also very good. And it does not require much power also. No recurring cost. And in fact, the station soon it augmented to 20 points. And for 20 points, they used a Mega, Arduino Mega, because Mega has got a lot of pins. And Mega also has that hardware serial port. We did not use Uno here or any other. Yeah, Miss, yes, Anthony, please.
Can LoRa device actually act individually without a separate microcontroller?
No, LoRa cannot act on its own. SPI devices, SPI LoRa, they can act on their own, but LoRa cannot act on their own. LoRa has to be connected to some microprocessor. Whereas the SPI device, that LoRa device, they got a 2 digital pin on their board, but I never used it. They claim that that can be used independently. Look at here. This is the handheld device. It was made at the beginning. At the beginning, they made this handheld device on an Uno. These 3 parameters used to arrive here, and this is the handheld device. They used to test it going to the roof. Later, with the stationary antenna, they put it on a processing output. This is the processing output, Handheld 1, Handheld 2. And this is the megawatt, this is the head, and this is the tail race. An advantage of processing is that it can be ported, once it is made anywhere, it can be ported on any platform. Linux, Windows, so on any platform, you can transfer the output program. And you can, in the processing, you can put it in any, dump it in any database as well. I'll show you how data is coming here. I'll show you. And also, if on the receiving end, if you use an ESP32, the standalone, without any computer, without any handheld device, using a ESP32, you can dump data in MySQL, RDBMS, any RDBMS you can put. You can put to the cloud server. In fact, they did it for some time on thingspeak.com. They uploaded the data. I'll see if that cloud still works. And using ESP32, we can put it in any standalone web server as well. Now, before coming to the questions, I'll show you this output of the processing. See, this is the processing screen. Let's see where it is working. Up to 4629, it was working. See, data was arriving like this: 1.98. This is megawatt. This is the megawatt. This is the total megawatt. This is that head level, and this is the tail rest level. So that was all about this presentation. Now we'll open the question session, whatever time is available. We have 4 minutes time now. I am opening for the question session. If you have any question, just speak up.
Abhay is asking, instead of LoRa, can we use BCN595N BioT module?
No, I think this long distance you cannot do with those kinds of radios. Those works on 2.4 gigahertz, I think. No, you cannot.
Someone is asking about your advice to the undergraduates. How do we get this level of expertise? Is it by doing many projects?
Well, in fact, LoRa is the latest communication device. LoRa has, in fact, changed many dimensions of communication systems. So if you start working on LoRa, you will find that you can come up with many indigenous ideas, innovative ideas to create your own project. So you need not to work for with this sort of devices for many days. You just get hold of some LoRa device, get hold of some microprocessor, and start tweaking. We'll find that LoRa is such a wonderful device. You can come up until number of projects if you be a little bit creative. Because I have used LoRa in many devices. In many projects I have used. Like in a power plant, I am a power plant expert. In a power plant, nowadays we find that we need not to go to the site for seeing the temperature or seeing the pressure or whatever it is. Just using a LoRa device or communication system, we can get those data jolly well in our control room. Similarly, in the agricultural field also, LoRa has got very wide use. In the solar field also, LoRa is gaining communication, gaining momentum, because LoRa can be used for transmitting that strings voltage and current level. LoRa can be used in a mesh formation, like a network. If one LoRa fails, the nearest LoRa will take over. So LoRa has got a lot of possibilities. And in fact, this project is possible only because of these LoRa devices. If there was no LoRa device, we could not think of this project. Yeah, for one question is that how you suggest a few company who is making LoRa devices. Semtech is one company. Then XB also they are going to manufacture. I think they are already on the market. Then a lot of third parties are already in the market. They are buying from these original suppliers and they are putting their stamps and they are supplying you. eByte is a company with is a Chinese company, but they have got their suppliers spread all over the world. In Thailand they have, in US they have, in Europe few countries they have. So nowadays they are delivering from there. Earlier they were supplying from the Chinese suppliers, but because our government bans Chinese supply, so now they are finding their way from the Europe and Malaysia. eByte is a good company, and SPI you will find many suppliers are available on the market. But I always prefer this UART type. Yeah, how can get your contact details? Can you full details, sir? You can get it from EFY, or you search me in internet, Bera you search plus electronics or EFY, you will get all the details of mine. In fact, a couple of years ago, I did a project on LoRa relay. Means we are getting data from one company's ASDIC. So they are transmitting data from ASDIC, which is out there somewhere in 13-14 kilometers away from the power plant. It was not in the line of sight. So they brought data from ASDIC to their boiler head. So one LoRa is sitting at the boiler head and it retransmitted to the ground level. So that way LoRa can be relayed. Can you suggest some current to voltage converter module? Yeah, you go to the Banggood or AliExpress.com, you will find just write voltage to current converter, and you will find those devices available less than 1.2 or less than $2 available each piece. Yes, LoRa can be used in ad hoc network. Can it be connected with BeagleBone Black? Yes, it can be connected. BeagleBone has this hardware serials. What are the possibilities, the projects that can be done for home automation? You apply your imagination here. There are a lot of probabilities available here. Lot of probabilities. Sky is the limit. What is the sampling rate of the loop currents, and what is the reason to choose that for this plant? Aswath, can you clarify this question? I am not getting this question. What is the sampling rate of the loop currents? We are not using any loop current sensor here. So one question is Ranveer, where to get good LoRa antennas, 433 megahertz as well as 868 megahertz? Why are you going to waste your money for that? You just see the 3 into 10 to the power 10 is the speed of the light. Divide it your megahertz, you will get the lambda wavelength, and you divided it by 2 or 4 or by 1. That's the length of your antenna. If the size is perfect, that antenna will work. Otherwise, go to Amazon.in, you will get 868 megahertz antennas. I mean 4 to 20 milliampere loop currents. Here, see, if you put just 250 ohms resistance, then 4 into 250 will become 1 volt, and 250 into 20 milliampere will become 5 volt. So you can put an Arduino there, 5 volt Arduino you can there. It will give you 1 volt to 5 volt. So 4 to 20 milliampere is converted to 1 to 5 volt. So that way you can do. That cheap, the board what is available in the market, that does only that thing. So can you suggest some current to voltage converter module? Yes, those are plenty available in the Banggood or dx.com or AliExpress or Alibaba. Those are available there. Or you just connect it with a suitable resistance like 4 to 20 milliampere by 250 ohms resistor. You can get it converted to 1 to 5 volt. Yeah, any more?
Someone has asked engineering project that can be done using LoRa device.
Yes, using LoRa you can go for agricultural sector where the pumps will be run automatically, and it will when depending upon the dryness of the ground, the pump will be run automatically, which will be given command from the microprocessor. And once the pump started, it gives a command to the receiving receiver somewhere situated somewhere at the house of the owner, telling that the pump has started. Or sitting at the home, the owner can start the pump, monitor it. Also, the LoRa can be used during flood situation. LoRa can be set at strategic locations in the villages, Mohukumas, where the low-lying fields are available, and those will be running on solar panels. So once the flood level increases, the water level increases, it will be measuring water level continuously, and it will be transmitting to the city center. So like a mesh, you can monitor the flood situation all across the district or low-lying areas. And these LoRa devices run on very small power. So one 5 watt to 10 watt solar panel will be enough to run it during daytime, and a small battery below it will be acting as a buffer supply during night time. So that way this will be maintenance-free LoRa signal transmitter for the low-lying areas. This is one good project. The other projects in engineering, you can use LoRa for your quadrocopters. You can use long distance quadrocopters. You can use with LoRa with little more ingenuity. You can use it for what is that? Your college activities like the weather of your what is that? Weather forecasting. Using a weather sensors like DHT sensors, you can measure temperature, hygrometry at that there, and you can transmit it to your headquarter. You can find it there. The rain situation you can find out. So using LoRa you can do a lot of things. So engineering college, I think a lot of colleges, they are doing this LoRa based projects.
So thanks a lot, sir, for the lovely session.
Yeah, thank you. It's a pleasure.